Yes, please tell me. What is sense of this diagram? What is diagram is saying to us?
Sir, all entities have only one relationship.
Okay, so
Yes.
how many
Sir, I
relationship?
think it's
So how many entities we have with this
Sir,
relationship?
three.
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 Okay. So according to the ternary, we can say we have a relationship between all these entities. Those are the three. So when we have the minimum three entities and all three entities are connected to a single relation, at the time the relationship is known as the ternary, and by default you are communicate to the one entity to another entity at the time you are following the binary relationship. And this kind of the question may ask into the examination in different way. Okay, explain the binary relationship, then you will get confused. Sir, you did not tell us, you did not tell us about the binary relationship. By default relationship will be the two way, or we can say the binary. But in the ternary relationship, what we have new thing, we have the one entity, second entity, and third entity. So job entity, employee entity, and branch entity are connected to works on a relationship. So this relationship or this relationship point that is a works on is just connected by the three different entities, those are branch, job, and employees. And if of course employee and branch and job also having own different attributes, there is issue. So at the time this relationship is known as the ternary. Now, in this diagram, we don't have the mapping cardinality feature. So we can also include like this one. Employee works on the branch. So one employee can work in a one branch. An employee cannot work on the multiple branch. If he or she is doing so, we can put over here one to many or one to one. So we can say an employee can work in a branch only. So I can write the mapping cardinality like one to one. Now, is it okay? Or any doubt you have?
All clear, sir.
Okay, so an employee can have a job. Okay, so what he is belong to the, so an employee can have the job. So here we can put the one from employee side, but from the branch side we can have in a branch there are many jobs are available or various posts are available, like we are looking for an office. Okay, in the office we have the receptionist post, we have the manager post, senior manager post, we have the office assistant post. So we can put over here like the n. So from the this side we can read a branch can have the multiple job, or from this side we can read as an employee can have the multiple one job only. Okay, so this is the point. You can explain your ER model with justifiable point. So this is a ternary relationship example. Okay, by default it is following by the only the binary relationship. Now it is clear to all. Tell me any doubt over here, then you can ask me. Yes, please tell me. Do you have any doubt?
No, sir.
no doubt, sir.
Okay, so I'm just moving to the my next part, that is the extended ER feature, and this is the most important part for the today's class, and this is the last part of the ER model learning. And after this class or after this concept, we will see the another concept tomorrow. But before that, we need to understand the extended ER feature and what is mean by the extended ER feature, and that is those are recognized by the specialization, generalization, and aggregation. And very truly speaking, these concepts are inspired by the UML. Okay, and this UML is known as the Unified Modeling Language. When you're looking for the concept that you are Unified Modeling Language, and in any object-oriented programming feature. So when you are looking for the any object-oriented programming followed by the UML, or if we are looking for the object-oriented programming concept with graphical way or pictorial representation way, that at the time the UML, that is Unified Modeling Language, play important role at the time. So if you are not studying object-oriented programming without UML, then you are not learning object-oriented programming in proper way. So Java you are learning, and C++ you are learning, then you must follow the UML notation or UML diagram. So what is a UML? And that is a part of the object-oriented programming. So, but this extended ER feature is completely inspired from the UML. So right now, UML is not necessary to describe all the point, but we need to understand where the specialization, generalization, and aggregation terms comes from. So we need to keep in mind all these terms are coming from the or inspired by the UML. Now let us start from the very beginning part, that is spillation, and you will be happy to know the answer of all these points. Okay. So now generalization, spillation we have. So I'm talking about the spillation first. I'm reading the few point over here, then you can understand if you are familiar about the top-down approach or bottom-up approach. Yes, student. Tell me any idea you are familiar with the top-down approach and bottom-up approach? Please tell me. Any idea you have top-down
Yes,
approach? Yes.
like C plus plus is top-down approach like that.
Top-down approach. Why it is known as a top-down approach?
So because first the compiler understands the code from the top, like from the header files, and then it goes down.
Okay, so this is the top down. So what happened when looking for the any program? Okay, without object oriented feature. Okay, without the object oriented feature, if you are writing a program, then it will be read by the compiler from the top to down. So you can see the first instruction will be executed first, and then second, then third, then fourth, and fifth. So execution of the instruction will be from the top to down without any problem. So this is a sequence which determines that is we are looking for the information from the top to down approach. So spillation will work like this. Okay. So what happened into do we have to do into the spillation under the ER model concept. You can read out this point. Spillation is a process of identifying subset of entity that share different characteristics. It breaks an entity into the multiple entities, and from the high level, that is super class, to lower class. And we also recognize all these classes into the super class to subclass. Okay. And the breaking of the high level entity is based on the some distinguished characteristics of the entities in super class. So it is also known as the, or it is follow the concept which is known as the top down. Okay, yes, please. Student, can anyone tell me a real example you are looking for such concept of the aspiration you are looking for? Any idea? Yes, student, please tell me any example you are looking for, real example. Yes, please, I need the answer from your side. Please do fast. What is mean by the aspiration in ER model? Any idea, any students who are having? If you don't have any idea, then say yes or no. So I will not be much worry about the concept from your side. Yes, please tell me. Any doubt? The explanation you have, you are remembering an example?
No, sir.
Okay, so I'm taking the entity set right now for explain this concept. Now we have the student entity. Can I break this student entity into the two different levels? Now tell me, can I break? Is it possible to break these this into student entity into two different entities? Those are the,
Yes, sir. Yes, sir.
so those are known as the regular student, and two are known as the X student, regular student and X student. So this is what this is known as spillation. I am doing spillation into the my ER model to break the student entity into the its different sub entities. Those are the regular student and X student. So this is a real example. Is it clear to all? Okay. I can take the another example like account number. So account can be split into two different category. One is saving account and another is a current account. Can I do? Yes, we can do. This is known as the specialization. Okay. Just please tell me any doubt in this point.
No, sir.
Okay. So now I'm coming to the my important point over here, that is generalization. So what is a generalization? We have generalization is a process of generalizing an entity which contain generalized attribute or properties of the generalized entities. The entities that is created will contain the common feature, and generalization is a bottom up process. Okay, so this is the point we need to keep in mind. Generalization is a bottom up process. So we will understand this concept from bottom to upside. So you can understand there are three entities, sub entities. Those are the car and truck and motorcycle. Okay, we have the entity that is a car, we have an entity truck, we have the entity that is the motorcycle. All these are under come into a category of main entities. This is known as a vehicle. Can I say? So we can understand, we can write this point: car we have, truck we have, and motorcycle we have. So this is a vehicle entity. All these are connected by this one, but we can read all these entities like this one. So this is known as the bottom to up approach. Okay. Now tell me, is it clear to all? What is mean by the generalization and what is mean by the specialization? Please tell me. Any doubt you are having, then you can ask me. So these two concepts is clear to all, and have you remember all these concepts from the top, but the programming object oriented programming, where you have understood the concept about the top-down approach and bottom-up approach. Okay. Now, is it clear to all? Please tell me, is it clear to all about the
Yes.
generalization? Okay, so here I am picking a real application when you can say how to represent such example into our ER model. So this is the point we need to keep in mind. So if we are reading this point from top to down, we have the same example. We are reading same example from top to down. Then we have the explanation. Okay, keep in mind. So vehicle is a, we have the vehicle. So vehicle, car. We are dividing all these. We are dividing the entity vehicle into three sub entities. Those are the car, truck, and motorcycle, and you are reading the same concept from bottom to up approach, then it is known as the generalization. So we can read this point over here: car is a vehicle, truck is a vehicle, motorcycle is a vehicle. So why we are using a disjoint. This is known as a disjoint disjoint notation, and this is known as a, I'm writing over here, this is known as a disjoint. In mathematically we can say this is known as a disjoint is a notation. Okay, is a notation, and this notation is used in extended ER model while studying the specialization, generalization, and aggregation. I was coming on the aggregation, but let me know the more detail about the specialization and generalization. Now, it is clear to all this concept, specialization and generalization. You have any doubt? Then you can ask me, please. Tell me. You have any doubt? Just let me know. It is clear to you. Yes. Any
No,
doubt?
sir.
Okay. Now, what do you mean by the aggregation? So, let us understand the aggregation term in simple way. Uh, okay, we were coming the part and just I'm taking real example for the both example of the generalization and inspiration. So here I am just putting an example. Now you can understand this example. Now person is an entity. Person is the entity, and this person is an entity. It is divided into the two different sub entities. Those are employee and customer. Okay, just look only the this part only, just half part. Don't think about right now employee your part. Just look only the this part only. So we can say person is a person is a employee. A person could customer will be a customer will be person and employee will be person. If you're reading this point from top to down, then what we are following? We are following the generalization. If you are reading this point from what up to down, then we can say this is a this is a specialization. Okay, so keep in mind all this point. Now, why we are dividing? Now, question comes in our mind: why we are dividing? Sir, person will be okay, no problem. But we are dividing. This is the sense why we are dividing, because a customer can't have the salary. A person will be an employee, no problem. We can give the information about the employee and customer. There is no issue in a person database or person table. But we need to specialize or we need to generalize. Why? Because employee can have the salary, but customer can't have the salary. So at the time, we need to justify with all the attributes and which are having or associated with the entities. Customer can give the credit rating or customer can have the product. Okay, so this is the point we need to keep in mind, and customer will pay the bill. Okay, so we need to look things all those things. So where the specialization and generalization is required. This is the point. Now in this diagram, what the things we have updated. Now you can read again from this point from this part. So an employee will be, or an employee could be officer, tailor, or secretary. Okay, so secretary can have the R work, but tailor can have the station number and R work, and some kind of post we can say. An officer is the officer number. So I'm saying as a person database, I'm taking real example. The person database in every VIT Global University, then you can see that there are three different kinds of persons we have. We have student, we have faculty, and we have the staff. In the faculty, we can categorize all the information into department wise as well. So we have the CS faculty, we have the double A faculty, okay, or EC faculty, or we have the mechanical faculty. But we are looking for all those things or associate with the simple or single relation, that is the table person relation. So the particular table. So why we are dividing? Because if we are dividing all those things in a respective manner, then we can troubleshoot or we can modify the information in simple way. This is the main objective for using the year model in extended way, followed by the specialization, declaration, and aggregation. So this is the second example. Secretary can't have the things which should be related to the officer, but that is also an employee of an organization. So look this example. This is another example. I have taken this example from the course book and which is the standard example. So that's why I'm putting this example into my another example category or set. Not a way. So specialization and generalization is clear to all. For any doubt you have, then you can ask. Yes, please tell me any doubt you have.
No, sir.
No, sir. Okay, good. So now, last point that is we need to look for, that is aggregation. What do you mean by the aggregation? Since aggregation determine like the inheritance. When you have studied inheritance in object-oriented programming, then you can understand the children is a part of the father. Okay, and a father has many children, so we can see the information from top to down or bottom to upwards, of course, without any problem. So we need to look this point. What is mean by the aggregation? So aggregation is like similar to inheritance into the C++ programming or Java programming. So we can inherit the one class feature into the another class feature. Same thing we can say A class is a part of the B class. Like just this one, just let me talk. I'm inheriting the property of the A class into the B class. Okay. So we can say B class is a part of the A class. So I can represent this is a part. Okay. So B is a part of the A or A is a part of the B. From which direction you are reading is we can see. And or we can determine like this one. A has a B. Okay, so we can say A is a father. Suppose A is a father and B is a child. So father has a child. Okay, and child is a part of the father. So we can read out all the information like this. Now, this is a real example I'm taking right now. It is clear to all. This is the sense of the aggregation. Aggregation is completely inspired by the inheritance from the object-oriented programming. So that's why I'm just focusing on the concept that is inheritance. So aggregation represents relation between the whole object and its component, and we can represent such relationship like has a relationship or is a part of a relationship. And this concept you can see into the inheritance, into the object programming, but into the ER model you can see employee manage the manager. So through the relationship he can manage, no problem. Employee works on the branch, there's no problem. Okay. Employee, okay, so this is the point. Employee works on a job, and a job is connected to the branch. So we can represent such point over here. A manager manages the job. So you can see from this diagram, employee has a job. So we can represent this relationship like this one. Employee has a job. Okay, and job is a part of the branch, or we can say manager has a job. So we can also represent this relationship like this one. Manager has a job. Okay, and manages the branch. So you can represent this part instead of putting the has a. You can say is part. Okay, instead of putting the has a, you can say is a part of the job. So manager is a post which is a part of the job. We can say. But this is not the aggregation. Aggregation. Now tell me any doubt over here, then you can understand this concept. Now tell me any doubt. Yes, please tell me any doubt you are having.
No, sir.
Okay, so specializations example I have taken through the students and accounts as well. So any other student who is remember something about the aggregation? Any other example? Yes, please tell me any other example you are looking for. No example? Okay, now tell me any doubt for today's class so far. We have seen what we have seen. We have seen three different ER model, including previous class. Okay, and now we have seen the extended feature. Just let me write correctly. Uh, extended feature of ER model. Extended features of ER model. In this, what we have seen the specialization, aggregation, and generalization. Let me remind you all once again, this specialization and aggregation are the inverse of each other. We can say in specialization, what we need to do, we need to use a top-down approach. In generalization, we need to follow the bottom-up approach. But in the aggregation, this aggregation is completely inspired by the inheritance concept, and it is also known as the is part of relationship, is part of relationship, and it is also known as a has a relationship. So this is the summary of the today's class we have seen. Now ER model is completely finished from the my side, and at the time to time we will see some new things which is could be the part of the ER model, and of course we will see the new concept. Okay, so any doubt so far you have? Then please tell me any doubt. Yes, please tell me any doubt you have right now.
No, sir.
Okay, so I'm just giving an exercise to you right now. I'm just draw an AI diagram, and I need to do a few things, and that is the most important part. As I told you, student is my entity. Simple exercise I am giving to all here, and I need the answer from to all students. And what are the various attribute of the student? That is student ID. Of course, this student ID will be the unique. So I'm putting this point over here into the simple way, like key attribute. And the student has a own name, so student name will be the concept of the student name and student age I am looking for, and last part I'm saying that is the address. Okay, and that is enough. I'm not talking about the permanent address or local address. I'm just putting only the one attribute, that is the address. I'm not looking for this concept as a composite attribute. Okay, what is this? Can anyone tell me what is this? Can we say this is a ER diagram of the student? ER model of the student? Can I say this is a ER model of the student entity?
Yes,
Can
sir.
I say? Okay, everyone is agree with me?
No, sir.
But into the practical way, if I need to perform any operation on this entity, then I can't perform because this is a graphical way. So what is my responsibility? And that is it should be transformed converted into the relational model. Okay. So here, what is the we have the option that is a transformation. Okay, or we can say conversion, transformation or conversion of this ER model
Sir,
into
I'm
the
out.
in the relation model. Yes, tell me any doubt in this diagram. Just please
Sir,
tell me.
in the ER model, sir, basically we have a relationship between entities, sir. But here we have only one entity. So how can we
Okay,
prove?
yes, my dear. This is a simple question you have asked. In ER model, there's no relationship is required, but we are only the drawing only entity, then it is also sufficient part. But there's no guarantee in entity relationship model, ER model, there is a relationship should be inquired, there should be the relationship diagram. Only entities will drawing, and that is also part of the entity relationship model. And
Okay.
this is a ER model of the student entity only. Okay, so I am not showing any relationship between the other entities right now. Okay.
Okay.
Okay, now if we need to transform this student ER model into the relational model, so what I'm doing, I'm just transforming my concept ER model to the what I'm doing, I am doing ER model to the relational model. So this is the concept which is known as the ER to relational model. And from the next class, we will see the various object and construct and structure and architecture of the relational database relational model. So that will be the my concept. But why we are looking for? So this is the objective we need to understand before understanding the new idea. So the graphical representation, okay, we can understand what is happening over there. But we can perform any operation only the relational database or relational information what we have. In tabular way, that is row and column. But we can't perform any operation on the graphical way. So we need to do, or what we need to do, we need to transform such ER model into the our important model that is known as a relational model. And from this point, we will start the concept that is relation model, and that we will start from the tomorrow itself only. But here I'm just giving the summary, or I'm just giving the this idea that how we can transform. Now you can see. So student will be the our table name or relation, as I told you. So in ER model, student will be the entity relation. Into the relation model, student will be the name of the relation. So only naming convention we have, or general what we have. This is known as a table. If I'm making all these things, then what this attribute will be transformed into the its field name or column name. So I can write or I can design my model like this one. So you can say what is my first attribute name, that is a student ID. So I can make this a student ID. And next table, next column name or attribute name will be the as name, that is what we have student name, of course. Okay. And this is what we have the another option, that is the age we have. And last part we have the address. Okay, and we can store any information into a tabular way only, and that is followed by the relational model only, not into the ER model. So ER model is what? ER model is what? ER model is nothing which is only the graphical representation of the entities as well the its relation between the other entities as well. Okay, so just let me complete this diagram. Suppose I have the two record. So suppose I have the three records, one, two, three. And let me remind you all once again through the different color, then you can understand what is the sense of using. In relation model, this is known as a relation. Okay, in general way, it is known as a table. Or in this ER model, it is known as a entity. in a model, it is known as a attribute, but in the relation model, it is known as a column name or field name. Okay, so I can put the here that is a field name. Okay, field name, or in general we can say column name, and this is known as a record in general way. We can say into the relation, it is known as a record, or in general we can say it is a row. So this is known as the records. Three records we have, and the value which is contained by a column like this one. So this all these are the data values and set of the data values of a certain or specific column, and it is known as a domain. Okay, it is known as a domain. So this is the point from which we need to start the relational database. Okay, now is it clear to all this concept, why we need to study the relational model? Just please tell me, is it clear to all this concept?
Yes, sir.
Okay, okay. So